So here we have already R1 plus R2 is equal to 4R cos square C by 2. Right? Now what we have to prove that here delta is equal to R1 R2 into root over 4R minus R1 minus R2 whole divided by R1 plus R2. So now what I am doing is taking the RHS. So RHS is we have here R1 into R2 into root over 4R minus R1 minus R2 whole divided by R1 plus R2. Now here for this R1, so I am writing as it is, that is R1 into R2, and this is into here root over, so 4R. So if you take minus common, it can be written as R1 plus R2 whole divided by R1 plus R2. So now here you have R1 plus R2 is equal to 4R cos square C by 2. So now which is equal to, here for this R1 writing delta by S minus A into, so this is delta by S minus B into root over, so here 4R minus, so here R1 plus R2 is 4R cos square C by 2 cos square C by 2 whole divided by, in the denominator also replace R1 plus R2 by 4R cos square C by 2. So now here we get delta square by S minus A into S minus B, so into root over, so here we get, so if you take 4R common in the numerator, 4R into 1 minus cos square C by 2 whole divided by, so this is 4R cos square C by 2. So now 4R gets cancelled in the numerator and denominator. We have here, so which is equal to delta square by S into S minus A into S minus B into, so root over 1 minus cos square C by 2 which is sin square C by 2 whole divided by, and denominators we have cos square C by 2. Cos square C by 2. So finally what we can write, so which is delta square by here S minus A into S minus B into, this is root over cos square sin square C by 2 by cos square C by 2 which is root over tan square C by 2. So now square and root gets cancelled. Here delta square by S minus A into S minus B into here tan C by 2. So we have one more formula for tan C by 2 here, delta square by S minus A into S minus B into here, it can be written as, so S minus A into S minus B by delta, we have one more formula for tan C by 2. So that's why here in the numerator and denominator S minus A and S minus B gets cancelled, and in the numerator delta gets cancelled, so which is equal to delta, which is the LHS. So therefore we can prove that, so this is LHS is equal to RHS, so that is delta is equal to R1 R2 into root over 4R minus R1 minus R2 by R1 plus R2.